I am going to explain to you how we do the Lewis dot diagram structure of ionic compounds. Now, before we begin, first of all, we need to know which elements in the periodic table are metals and non-metals. Metals, they always lose electrons and they become positive. And the non-metals, they always gain electrons and they become the negative ions. Here they are called anions, and here they will be called cations. Now, how is that? Elements of group 1 over here, they make a positive 1 charge except for hydrogen because they lose 1 electron. Elements of group 2, they lose 2 electrons and they make a positive 3. And elements of group 13, except B, they make a plus 3 charge because they lose 3 electrons. Elements of group 15, they gain 3 electrons and turn into negative 3. Elements of group 16, they gain 2 electrons and they do a negative 2 charge. And elements of group 17, they gain 1 electron and they make a negative 1 charge. So let's begin with our first example, the Lewis dot diagram of potassium iodide. Potassium iodide. So first of all, where is potassium? This is potassium and here's iodide. Always follow this rule. You write the symbol of the elements before and then you separate them with an arrow and then you write them again after. Before the arrow, you do not put the charges. After the arrow, you put the charges. So for example, here I is negative 1 and K belongs to group 1, it's positive 1. So I write K plus 1. Now follow this rule. The positive ions don't put a single dot on it because all the valence electrons were donated and given to I. And every negative ion, you have to place around it 8 dots. So this is the Lewis structure of an ionic compound. Now before doing so, K is in group 1, it has 1 valence electron, and I is in group 17, it has 7 valence electrons. That's it. You're done. Now let's take another example, the calcium oxide. So first we write the symbol of the elements before and after the arrow. And then we determine the charges. So here's calcium is in group 2, so it's gonna have a plus 2. And here's the oxygen in group 16, it's gonna gain 2 electrons and have a negative 2 charge. So again, the positive ion, you put for it the charge without any dot around it. And the negative ion, you place the charge and you put around it 8 dots. So always remember, the positive ion, no dots around it, just the charge. The negative ion, you put around it the charge that it is formed and 8 dots. Now, before this happened, calcium was in group 2, so it had 2 valence electrons, and oxygen was in group 16 with 6 valence electrons. Now let's move on into more complicated examples. Lithium sulfide, lithium and sulfur. Lithium group 1 and sulfur group 16. So lithium will do a plus 1 and sulfur will do a negative 2. So here's lithium will do a plus 1, no dots on it, and sulfur will do a negative 2 with, you draw 8 dots around it. Now again, before transferring the electrons, lithium had 1 electron and sulfur belongs to group 16, so it had 6 valence electrons. However, when we look at the charges, we find that over here the charge are not balanced. I have a positive 1 for a negative 2. So you just do the X rule. So this number over here, number 2, I'm gonna change the color, number 2, you just place it next to the lithium, meaning that I need another lithium. Or you can simply add positive charges to equal the negative charges. So if I have 2 minus, I'm gonna write 2 pluses next to it. Another example, magnesium bromide, magnesium bromide, magnesium bromide. Now if I look at the periodic table, I find that the magnesium belongs to group 2. So it's gonna do a positive 2 charge. While bromide is over here, it's gonna have a negative 1 charge. So again, the rule says for positive ions, no single dots. For negative ions, you place 8 dots around it. Now, magnesium was in group 17 with 7 valence electrons, and magnesium belonged to group 2. Now, for this one, I have 2 pluses, but I only have 1 minus. It means the minus is less. So you write again 1 more Br to neutralize the compound, because in an ionic compound, the charge must always be equal to 0. So having 2 Br from one side and 1 Mg, Mg1 and 2 Br from here. Now the last question, aluminum selenide. Aluminum selenide, Al and Se. Now let's look at aluminium. Aluminium belongs to group 13, so it has 3 valence electrons. Where selenide, it belongs to group 16, it has 6 valence electrons. It's gonna lose 2, gain 2, and aluminium will lose 3 electrons. So this is the aluminium, and this is the selenide with 6 valence electrons. The aluminium is going to completely lose those electrons and turn positive. And as I said, the positive ion, no dots around. And for the negative ions, you always place 8 dots around. So here, selenium belongs to group 16, so it will have a negative 2 charge. So I will place 8 dots with a negative 2 charge. Now, however, the positive and the negative are not equal, so we need to make them equal. The 3 that is here means I'm gonna need 3 selenium to have a total of 6 minus. And here's the other selenide with 8 dots and a negative 2 charge. Whereas, because I see here 2, it means I'm gonna have 2 aluminium, each one having 3 plus charge. Now, if you calculated the positive charges, total of 6, and if you calculated the negative charges, total of 6.